All right, we're recording. Hello, everyone that's listening to the recording. Welcome. This is our fifth meeting of the Compute Over Data Working Group, and we're very excited. We've got some stellar guests today. We have Jonathan and the Gridcoin team, who are going to give us an overview of the history of Gridcoin. It turns out that Gridcoin has been around for a very long time, and they're doing some really interesting things to benefit humanity, specifically around decentralized compute for research projects. And so we're going to let them give us a detailed breakdown there. And then in the second half of the session today, we'll hand it over to Charles, who has been working on some very interesting things related to multi-chain storage with Phil Swan. And so we'll get some details there. Before I hand it over to Jonathan, though, I do want to just give two quick advertisements. One for our in-person IRL meetup. It's going to happen. It's going to be November 2nd through 3rd in Lisbon, Portugal, just after the Phil Lisbon events the previous week. So please pencil that in on your calendars. And also, if you'll go to discourse.cod.cloud, love to have everyone in the community chime in with questions and see if there's some topics that kind of have shared interests. I just want to let everybody know that we do have that available now as well. So that's all I have for announcements. Jonathan, looking forward to hearing from you guys. So I'll hand it over to you whenever you're ready.
Awesome. Yeah, thanks, Wes. And as I share my screen here, let me know if it doesn't pop up. But I have been watching back over the recordings of these past episodes, past meetings, and they're very exciting. So I know me and Jim, who should be popping in here shortly, are both really excited to see what can come from this, because as you said, Gridcoin's been around for a very long time, and we've been part of a couple of these working groups over the years. And one of our fundamental mechanisms actually came from one of those working groups. So yeah, I will give a quick overview of the history and then jump into some of the details with what we're working with. So we are a coin. We are a layer 1 blockchain started in 2013. We shifted from a proof of work bootstrap to proof of stake in 2014. And the main unique aspect we're working with is a unique emissions mechanism that lets us do multi-incentives. So we currently incentivize blockchain consensus through proof of stake and BOINC contributions. So BOINC is the Berkeley Open Infrastructure for Network Computing. It sprang out of SETI at Home in 2004. SETI at Home is from 1999, though, so it's been around for quite a while. But Gridcoin, this emissions mechanism, can incentivize any point accruing or leaderboard system, and we'll get a little more into that later. In 2019, we figured we had about 3,400 unique staking nodes securing the blockchain, and that would put us at about 7th of all blockchain projects if you compare it to staking nodes or consensus nodes in 2021. So it is a fairly large project, albeit fairly under the radar as well. We have 16,000 active contributors contributing to these distributed computing projects on BOINC that are incentivized by Gridcoin, and 18 of the BOINC projects, and I think there's 30 some odd BOINC projects, but 18 of them are incentivized by Gridcoin. And then we just had one of our largest releases, which is manual rewards claim. We'll get into that a little later, but it's basically a form of delegated staking by requests, and it makes Gridcoin, as far as we know, the first effectively no cost entry for a proof of stake blockchain. You basically contribute distributed computing resources to a research project, earn your Gridcoin until you have enough Gridcoin to contribute to consensus on the blockchain through proof of stake. It doesn't require anyone to buy Gridcoin to start staking. We think that's very cool. So these are more BOINC contributions, but these are all coming from projects that Gridcoin has incentivized, and we contribute a significant amount of processing power. It's between 3 and 5 petaflops to the BOINC network. I think it's something like 20% of computation is incentivized by Gridcoin. Rosetta at Home out of the University of Washington and Institute of Protein Design modeled COVID before anyone else. They also developed with those resources a vaccine that they sold to South Korea. We've got Einstein at Home and a bunch of space projects that have identified a number of pulsars. World Community Grid, which used to run out of IBM, currently runs out of the Krembil Institute in Canada, has a lot of sub-projects, notably in medicine. They do cancer marker and treatment research. They also do some climate change projects and a whole bunch. There's a lot out of that one. ClimatePrediction.net runs out of Oxford. They've done climate simulation specifically. And then Goofy XGrid, and this is more important than it might seem, is a user sort of started project, because a big aspect of BOINC and Gridcoin is that it's permissionless. Anyone can set up a computation project with any data they want, and they are essentially guaranteed computation resources to get that data crunched. And we'll get into that a little later as well. But they determined that no, if you put all the monkeys, an infinite number of monkeys in a room with an infinite number of typewriters, they probably will not write Shakespeare. So with regards to how Gridcoin is developed, it is an entirely open source project. The people that contribute are doing it because they love the stuff they love. They love science, they love distributed computing, and they love science communication and participation. So as we, as a group, sort of start thinking about standards, I think it's very important to keep in mind how powerful the public is and how important it is to include them in the process of building whatever we end up building. That's not to say we don't have some GRC to play around with, although GRC is not worth much. So big number, little value. We got 15 million GRC in a community run wallet, and we use it for development when we can, some marketing initiatives, mainly community bounties. And like I said, it's not worth much. So it's more bragging rights than anything, but we have used it to fund development. And then we did implement something called side staking in 2018. This came from one of those working groups I was mentioning. Came from Pink Coin, which is, if you know Giveth.io, could be considered a precursor to Giveth. And it enables automatic donation-based funding. And along with MRC, it's probably going to lay the foundation for a future treasury structure that we're going to build. And with regards to sort of philosophy when it comes to development, we have been focusing on what makes us unique, which is that emissions layer and everything that's incorporated with it, and letting other projects focus on like blockchain and scaling and UX, UI, and all that stuff. So we like to experiment with different tools, then try to automate them, and then find out where we can iterate and improve. This is a graph of the repo activity since 2014 when we shifted to proof of stake. We also use an on-chain voting mechanism. So you can think of it like a DAO from 2014. It's not binding, it's not contractually binding. We are a permissionless blockchain. So whatever software is running on the blockchain nodes that's the ultimate choice. But this voting mechanism has been incredibly useful, in informing people on the decisions we're making, sort of letting feedback come into developers, letting developers know what will generally be accepted by the network. So it's stopped some developments in their tracks because no one would accept it, and it's helped us move forward in specific directions over the years. Move forward from that, and now we get to the fun stuff. So we've got the basic Gridcoin infrastructure, and this is a very old, very dense project, and we're going to try and simplify it a lot here. But basically, there are 6 layers we've got here, 5 if you remove the participant, but the participant we do think is probably the most important person, because again, this is all open source. This is just what people have contributed to the projects over the years. There was no funding for this thing. You've got starting from the bottom, then the participants, the statistics providers, which are BOINC projects, or any other computing platform, so we can incorporate folding at home or Bakoyao, which looks very interesting. We could also incorporate any point accruing system. So one of the examples we use is we could incorporate Olympics. Like we could use our mission structure to reward anyone who gets a gold medal or a bronze medal in the Olympics if we wanted to. And then on top of that, we have our Beacon ID. On top of that, we have our oracles. Then we have our incentivization mechanism, which is the bulk of everything. On top of that, we have the base layer, the blockchain and economic protocol. So statistics providers, as I said, any point accruing system, they're entirely independent. They do what they do, and we bring them into the network by using our voting system. So it is up to the network participants to verify and vet these statistics providers and say, hey, these guys are not going to cheat, or they're doing the right stuff. They're aligned with our network values. We're going to vote them into our incentive structure, which will incentivize the contributors to these statistics providers through the emissions layer. Once these statistics providers are added to the incentivization mechanism, they are basically guaranteed incentivization. They are guaranteed an amount of computation resources and a chunk of the GRC that the protocol mints. The Beacon ID is essentially a way to verify and identify contributors to these computation projects. There is a process that a user goes through to verify they are who they say they are, to verify their wallet is connected to the statistics provider they are contributing to. And it's so far worked very well. It is the only required cost to enter the system. It was once only a transaction fee. I don't know if we've shifted that to like a 1 GRC fee, but maybe Jim can enlighten us a little later. But it is a very, very low cost. So that's why it's effectively a no cost entry to the POS system, but it's effectively no cost, right? So oracles are the scrapers we use to collect the statistics from the statistics providers, the contributions of all the people contributing to these various projects. It's collected by these oracles. They do a whole bunch of stuff with it. It's just outlined on this page. And there is a lot more technical detail when it comes into the oracles, but they essentially collect it, send it off to the blockchain network, and the blockchain nodes, not the oracles, come to consensus on whether or not the oracles are being truthful. So it is a very decentralized system. The oracles do have some amount of trust in them, but really most of the trust is on the blockchain network. We thought that was very important as we develop our decentralization, as we develop our mechanisms to keep things as decentralized and trustless as possible.
Yeah, I mean, going back on the Jay Ringo or John, the only really caveat with the oracles is which is part of the vetting process for approval of an oracle, is to ensure they're independent, right? So that one individual is not running more than one oracle, so that allows us to effectively treat them as transparent. In combination with the way they're publishing stats. We can talk more later, but that's super important to us to achieve transparency. And I'm not sure there's, I haven't done a complete canvas of the whole space, but I mean, I don't know of too many instances where there are multiple oracles operating in a consensus basis that effectively are having the nodes cross-check their work so that you can eliminate the oracle as a trust factor issue, right? It's a big thing on collecting off-chain data to solve this problem.
Definitely. Those, by the way, Jim, when did you implement those? That was
3 years ago. Yeah, it was a while back. That was the first one of the first major technology pieces we put in place to solve the centralization of statistics collection problem, along with load on the statistics provider, right? So that before each node was downloading the statistics directly and trying to do its own comparison, and it was killing the projects because it was like a DDoS attack. So to eliminate the scalability problem, we implemented these oracles, and then the oracles, of which there's 6 on mainnet right now. There can be an arbitrary number of them, although it's silly to have more than about 10. For a lot of different reasons, but 6, they download the statistics, and they also they check the statistics on the project sites for changes, right? So we're looking at the hash of the statistics or ETAG as we pull those down over HTTPS, and if they don't change, we don't download them again. So it's a very clever approach to pulling that data to minimize the amount of load that we're placing on the external data providers.
Yeah, and highly effective. It's been running, like you said, for 3 years nonstop. Yeah. Very few problems, if any. And they did solve the problem we were coming across, which was we're DDoSing these BOINC projects when we try to collect statistics.
Now they can't even see the load that we're putting on.
It's great. All right, so moving along through the layers here, we then get to the incentivization mechanism, which, as I've said, is multi-incentive. The basic way it works, there's a lot to this, but the basic way is we mint a certain amount of GRC per day, which is 37,600. And then 75% of that GRC that's minted by the protocol gets distributed to crunchers, or you can think of them as contributors to statistics providers. And then 25% of that 37,000 is distributed to stakers. So we have a constant block reward, we call CBR, of 10 GRC per block. That was determined by a network vote way back when, I think 2016, 2017. And it was a great use of the voting mechanism to come to consensus on how much we're going to distribute to crunchers, how much to stakers, and how much we're going to make the block reward.
Now, I want to make a comment on this. So the transition to CBR was really to solve a low difficulty problem. We had people, we used to pay people at the first layer by interest, which was time accrued. And people would just start their wallet to get on and collect their interest and then go back off again. In a proof of stake system, you need people actively staking, right? So we made a decision as a community, we're going to push towards a constant block reward, which would only reward you if you're actually staking. So the beautiful thing about that is we saw our difficulty go from like 3, and each difficulty unit in Gridcoin represents about 10 million online coins effectively, right? So we went from a difficulty of 3, which was 30 million effective coins staking at any one time. Our difficulty today is averaging 19. So we have
Highly effective.
We have 190 million out of a total issued mint of 400 million coins staking continuously, which I think is, I'm very proud of that statistic, that we've got half of the coins that have ever been put into existence for Gridcoin actually actively staking at any one time.
Yeah, it goes to the point that this is a field that we're working in, that the people who end up contributing to these projects are very interested in. They want to see this work, from what we have seen at least. But to carry on here, we've got 9,600 GRC per day for stakers, 2,800 GRC for crunchers, or again, contributors to statistics providers. Continuing with the incentive mechanism, we've got a unit called magnitude, which helps determine how much each contributor earns out of the GRC emissions to contributors. The reason we have this unit is because when you're doing distributed computing, at least when you're doing it on top of BOINC, or when you're allowing yourself to incentivize multiple different leaderboards, there's no standardized point system among all these projects. So we have to standardize the information that comes in within Gridcoin. We have to make it equal to itself. So we distribute the GRC to contributors relative to other contributors that are contributing to that specific project, a specific statistics provider. And magnitude is the process by which this happens. And it ends up creating a couple of very interesting sort of non-intentional but passive incentive layers. Because the way it works is essentially there's a certain number of magnitude, and that gets evenly distributed among all the statistics providers, and then a contributor earns a portion of that distribution based on their relative contribution when compared to other contributors to that same project. So if someone wants to earn the most GRC possible from the emissions, they have to get the highest magnitude. And the way they do that is they go to projects that don't have a lot of contributors to it. So if you have one of these citizen scientist projects like Goofy XGrid that has zero marketing at all, has zero funding, it's just run on like someone's laptop in a closet, and that project gets into the incentivization layer through the network vote, people are going to go to it because they get paid to, not because they were told it's a really good project, not because IBM has supported this project with a whole bunch of funds. So the only challenge for these statistics providers is to communicate their science to the network as best they can. And once they get on the network, magnitude is the reason they're guaranteed a portion of computer cycles. So I just described this for the most part, the crunching contribution distribution, and then that last sort of thought is the active education part, where a crunchy project, a distributed computing project, or any leaderboard is incentivized because we have so many resources. They're incentivized to educate a general population as to why their research is worthwhile, instead of just educating other scientists why their research is worthwhile. They need to get science communicators or otherwise develop communication material to get people to approve the incentivization of their project. And at the same time, on the other side, the participants are kind of passively incentivized to keep up to date on what these projects are doing, sort of scrutinize them for malpractice or security flaws. Because each project that's incentivized by Gridcoin represents, it's a value representation of what the network sees as valuable. So we want to make sure it's not like trying to hack the NSA or doing anything that's highly illegal. it's a very fun process to watch because people do have very intense debates about what makes quote unquote good science or good research. So we also use incentives for security. So because network participants are passively incentivized, we find security flaws, and we have found security flaws in several projects and helped them work through them and make their project better. And because of our magnitude distribution, every approved project is only responsible for 1/n of the emissions from the protocol. N is the number of projects incentivized by Gridcoin. So if one of them does get compromised, only that chunk of emissions is compromised. No one can monopolize or compromise the entire emissions schedule. And basically, the more projects that get incentivized, the higher the security goes. And because of that distribution as well, there's no way for ASICs to come about because each distributed computing project runs better on different hardware. They're different projects, so you can't build an ASIC to monopolize Gridcoin emissions. It's built for users. It's built for just people with like PCs and cell phones or servers to come in and get some reward for contributing to distributed computing. We've already been through most of this. We've run on proof of stake. We have these things called super blocks, which help with statistics aggregation and storage. We've got the magnitude, which helps with emissions distribution. And we are decentralized at many different layers, from the statistics provider to the magnitude system, to how currency is distributed, to our oracles. And of course, at the end of the day, the way we distribute the GRC rewards to people is they stake a block. So we're incentivizing people to get enough GRC to stake their own block. And once you can become a consensus contributor, then we are further decentralized. This is something to do with the MRC too, because the MRC makes it so anyone can get the rewards without staking a block, but we haven't seen how that plays out yet. When it comes to the users and the values, so the most important layer of Gridcoin, the participant, permissionlessness is the key to everything we build. A lot of us have been contributing to BOINC for many years, since before crypto was even a thing, before blockchain existed. And BOINC itself is a permissionless system where anyone can come in and create a distributed computing project. And as long as they can convince people to contribute to the project, they get their data crunched. With Gridcoin, we developed incentives that guarantee data crunch. You don't need to convince anyone. If you can just convince people once that your research is worthwhile and you can get in the network, then you are guaranteed computational resources. And we believe that at our core. Anyone should be able to set up a project. Anyone should be able to receive computational power for free. But that's not to say you can't build business models on top of this. If there's a base layer that just says you come in and you get 1/n computation power, maybe someone can get 1/n+1 computation power by doing something additional. And that would be layer 2 incentives, project creation and management, magnitude weighting. There's a lot of potentials there. We won't get into them here, but this is part of where we want to explore collaboration, is developing these new economic models. So we've been around for 3 cycles. We're entering the 4th right now. The first one, we kind of experimented. Does this even function? Is this a good idea? Turns out it was, because people kept it alive until basically Jim came along and stabilized the technology along with some other really fantastic core devs. And then for the past several years, been working on economic stability, getting that system worked out, getting MRC implemented, side staking, all that stuff. And in the next cycle, we're hoping to experiment, automate, and iterate once again. So we've got the experiments we want to sort of conduct have to do with economics. We want to see how these levers can be changed. And then we want to, for example, dynamic economics is changing the emission schedule based on the context of the network at any given time. So take in some information, change the amount of GRC that's distributed in which way. We want to automate the voting mechanism and the approval process. And we want to iterate on what types of projects we accept into the incentive layer and what sort of treasury structure we have. We do have a small one right now, but it needs to be built out, in my opinion. In terms of collaboration, this is where I think we can bring a lot to the table and where we want to learn a lot as well. So work unit verification, finding out work units are what BOINC calls the data packets that get sent out to users to crunch, to work on. So we want to improve the way that that work that is done by a user is verified, so we can know that it's good work. We want to expand the incentives and the economics of the system. We want to bring more different leaderboards into the system. We want to look at how business models can be built on sort of base technology that is rooted in sort of open source ideals, which is anyone can participate. We want to figure out how to use UX and UI to spur adoption, because I'm sure, as everyone here knows, this is a lot of technology that at the end of the day needs to be basically 1 or 2 click for a lot of people. And then when it comes to standards, social standards, for the way we view it, are sort of that permissionlessness aspect. Anyone should be able to build a computation project and get their research done. And we would love to see different levels of sort of approvals, like maybe a badge by some committee or something that says this is a permissionless system, it works this way, or this is semi-permissionless, it works this way. And then technical standards when it comes to application development and automation for these researchers. A lot of what we found over the years is that researchers don't necessarily want to go through the process of building out their application. It kind of needs to be 1 click for them as well. So if we can develop standards around how to sort of compile data, how to arrange data so that someone else can take it and just build that distributed computing application 1 click, that would be absolutely great. So that is Gridcoin in a nutshell. Happy to take any questions, and definitely looking forward to seeing how we can collaborate with any of the projects here.
Thank you, Jonathan. That was tremendous. I'll give some space in case anybody else on the call has questions for the team, and if not, I also have a couple of follow-ups for you guys.
I also want to second that. I mean, really tremendous stuff. You know, I think the layers between the how you do the orchestration and distributed distribution of the jobs versus the actual execution of the jobs, I think that's worth teasing out a lot here. I know that you don't own the computation, which is fine, but I know that a lot of folks here do want to, you know, participate in the computation, and I think it's probably something that goes beyond this conversation. But figuring out exactly how those various projects work together, I think will provide a lot of like really interesting, valuable layering. So you can have innovation in various ways. So, for example, let's say, you know, I'm a compute provider for, I don't know, Cuba. Because whoever needs to execute it on Cuba needs to execute the project needs to do it in Cuba only. You know, surfacing that through Gridcoin, making this a targeted compute provider, sharing the incentives between the two groups, I think would be really powerful.
Yeah, David, it's interesting. Implicit in some of the stuff that you might read into this is, you know, there are a number of blockchains that have tried to tackle this problem by trying to do direct compute on the blockchain, you know, distributed computing, and the idea that, you know, you can, let's call it proof of, you know, we even used to use this term and we don't use it anymore because it's misleading, proof of research, right? This idea that you somehow you can construct verifiable proofs on the scientific work you're doing. I've looked at this, and it's either difficult or impossible to really do that in an airtight way. And so, you know, where Gridcoin headed with this was a 2-layer approach, where we have an ironclad proof of stake layer for the base block consensus, right, to hold the blockchain together. And then the idea is that we put a 2nd layer on top, where we have a reasonable degree of assurance that we're providing a 2nd layer incentive based on external statistics measurements, right? And then, you know, there's some vetting that's done on a per project basis to make sure that we're not including bad projects. And then the projects themselves are actually responsible for validating and checking the work units that they distribute out, and then issuing the statistics on that. And then, you know, there, as John talked about, there are mechanisms of security built into the way we're doing the distribution of Gridcoin. We think that this is really the right approach, rather than trying to do an on-chain proof-based approach of research, which really, quite frankly, even if you could make it work, it severely limits the types of problems that can be done. And the second thing is, it's not scalable. The whole idea of being able to verify a problem, you have to do it on so many nodes that it goes directly against the whole idea of distributed computing. If all the nodes are computing the same problem, what are you doing? All right.
Exactly. Exactly. Yeah, I think again, this is certainly something that we're seeing as well. I mean, arguably, like if you, unless you're using a ZK proof,
Exactly.
you don't know the answer in the first place, so you
Right.
can't
And
verify
and
it.
you know that the domain of things that can actually apply a zero knowledge proof is very, very limited.
Very small. Absolutely. So again, this is something that we're exploring as well. The BackAI project is looking only as a computation provider. We are not trying to, kind of universalize job scheduling and things like that you are. And that's where, and I think there are many projects like us who want to be a compute provider or want to do something very specialized, but don't want to deal with or don't want to take on yet another kind of computation incentive layer.
Yeah,
so the idea of figuring out how to balance that is super powerful.
One of the interesting aspects from the BackAI project, from what I gathered from your presentation on the 17th, is the way you were going to look at maybe verifying different compute providers by just randomly auditing the work they do and then giving them a reputation score over time.
I actually like
there.
that idea a lot, because right now our vetting is effectively single shot, right? So we go through a process of, basically this is our whitelisting process. We go through a process of community. We have a defined set of standards to whitelist, and there's a trusted set. We have a whitelisting committee of trusted community members that goes through, and people nominate a project, and then they go through this procedure, and we look at different things, make sure they're doing what we call wingman work units. So they issue the same work unit to more than one node and cross compare the results. Because remember, the projects are doing the validation of the scientific work themselves, but that's sort of single shot, and we're not formally doing repeated vetting other than if we find a problem, right? And so there's a weak spot in that, and that, sort of the attention wanes on projects unless there's something that happens. I really like this idea of being able to measure and audit, even if you're, and you really don't need to do a large sample size to catch rampant cheating, right? If someone's doing something crazy.
Right? Totally agree. I don't want to distract from the entire group, by the way.
Like, these are great questions, but
yeah. For those that do want to get together, I think we definitely should figure out a place to join together, unify, and talk about some of these things, talk about the various layers. But I think what you're already doing is tremendous, and we very much want to support you.
Appreciate that. I mean, us solving the way to do that second layer was very, very difficult, by the way, to get all that to work and not kill consensus and cause forking. It bedeviled us for years until we finally cracked it in our Fern release, which was the big release we did a couple of years ago, and it is rock solid. And it's too gory to get into. I mean, John got into a little bit of it, but this is an area where we learned via the School of Hard Knocks how to put this whole thing together and make it work. We're not as scalable as a pure blockchain, because we're actually our underlying layer is vanilla proof of stake, which is very Bitcoin-like, right? So we have the same transaction rate limitation, but the second layer can actually be applied on another blockchain base that's not Gridcoin, that is more scalable. So that's something else to consider, is that, while we were never aiming for like absolute transaction capacity and all that kind of stuff, that really wasn't our aim. There are applications of this technology that could be done in a more transaction scalable approach. But
anyway, we're happy to talk about details with anyone. I'm looking forward to hearing Charles's
absolutely
presentation.
Thank you, guys. No, this is tremendous, and there's a lot more I think tech under the covers from Gridcoin that we'll try to get into a future session. So thank you guys for that. And so turning over to Charles. Charles, we're looking forward to learning all we can about what you guys are up to. In particular, I'm curious to learn if this is a technology that other COD working group members can be building on to make their integration with ecosystems easier. So if you're ready, I'll hand it over to you.
Yeah, thank you. Yeah, so can I see my screen?
Yes, looks good.
Okay, great. So basically, we're currently doing a layer 2 cross-chain solutions. So we can help Web3 project integrate computing street together. So currently, we see when people start using blockchain storage and computing, they were asking there are so many tokens, so many chains, and where to store the data, where to store to using the payment. So, and also like they need a whole basket of different things. For example, you need to buy ENS token for hosting website. You need to buy Filecoin storage token to hosting Filecoin, and then you need lots of other tokens. When you want to do different, for example, computing, you also need the computing tokens like Gitcoin, right? So then big problem for people saying like, okay, look, we need to handle a basket of different tokens, and then we need to integrate a basket of different SDKs. Then we can start doing some service work, like deploy a website, start some rendering work on top of that, which is really inconvenient. So basically, we want to solve the issue by provide one payment for all the Web3 services. So initially, like we're doing the first test try is based on IPFS and the Filecoin. So we enable people to using the Binance chain or Polygon chain to pay USDC, buy the storage, and get back the proof of on chain to the user. And the fund will be locked there until people start get the data on chain. And our next goal is integration of better like edge computing solutions and also city solutions to our network. So yeah, so like one example is about the NFT storage. We know like lots of people still store their data on the OpenSea or IPFS or AWS. So the issue is like AWS is quite centralized, right? So if a creator close bucket, it basically nothing. And if you're using the OpenSea, so OpenSea down, and you cannot see an NFT anymore. And also like IPFS good things, but issue like IPFS, there's the lack of incentive layer. So which means that if the node runner who turn off the node, you probably like not really get all the data distributed on the node. Those are all the issues. So currently, like we do a merchant storage. So basically, like you can using a wallet, a MetaMask wallet, to connect with, for example, Polygon network, and you can get the payment for storage. You can pay the storage on the IPFS. So here we give you the storage pin on the IPFS. At the same time, we are sending the storage deals up to 5 nodes. So which means that if you have a data loss, you'll be able to get the data back, retrieval back from Filecoin node, and adding back to your IPFS for the temporary usage. And after storage on chain, the payment will be, we're using Chainlink Oracle to unlock the data, unlock the fund, so the user and the storage provider can get the payment. So this is the basic technical stack. We're using upload a file, a document. So you need to pay with the Polygon token, and Polygon will lock it in the wallet. And then we are going to the exchanges to DX to swap the token, for example, from the USDC to REN wrapped Filecoin, like a REN Filecoin. After get a REN Filecoin, like IPFS storage will be caching your data. And we, at the same time, we are start backing up to the Filecoin network to 5 nodes. So each of the nodes will get the proof on chain, the DLID, and other information, or include the ZK proof. The Chainlink Oracle were in charge of bridging back those on-chain proof to the Polygon script. Theoretically, should be a smart contract. And when you get the on-chain proof, we know that the data is backed up successfully. Your fund will be unlocked. So which means that if you have 5 backup to 5 nodes, the only 2 nodes success, you only pay for the 2 success node. For the node who is not a success, you want to pay for that. And we also provide a capability to mint the NFT or the data on OpenSea exchanges, so you'll be able to transfer those NFTs. So we perform a 2 round of testnet. We get about 5,000 creators of 100 NFTs, and you can still click mint on OpenSea. We are going to launch the product officially in September. We give users about 30 GB free storage as a first-time user. And for every 30 GB, you need to pay a small amount of fund for using the services. Currently, like it's still pretty much low cost because MCS is a verified data provider of Filecoin ecosystem. So on storage provider side, we basically charge our nothing. We only ask a user to pay for the Oracle fees, which is gas free. So we currently have SDKs and a tutorial integration with JavaScript and Python. People are be able to uploading and try their data. Then they can automatically upload thousands of NFTs or storage pieces. It's already done by the community, and they have been tried a lot. And we ask them to write all the documents. And now we are in the process of a hackathon. So we have a special track for the computing of data, who is one want to doing the computing of the IPFS or Filecoin network using the New data or any scientific data. So we give a small demo about how to doing the computing of IPFS. Yeah. So I can do a demo here. Yeah. So this is the multi-chain storage. So here, like I've already pre-connected with my Metamask. If you want to upload storage, you can go here, choose any data you want. For example, I have a data set of something like a GIF. We can choose something small or medium size. I see like to the 1 megabyte, and they upload to the IPFS node. And we just approve that, which means that it will submit the create contract. And then after the contract, all the data funds will be locked there. Yeah. But this is for the testnet. On the mainnet, the first 30 bytes, 30 gigabyte, you don't need to pay. Yeah. Yeah, this was 30 seconds. Okay, so we see that you immediately get IPFS for training your data, and you start sending the data to different nodes. It take a while because they will carry all the available storage nodes in the network. For example, we can see like the different nodes who accept the deal in the past. For the deal not success, you can refund part of your funds here. And this is a past success deal. You can directly see that the deals on the on-chain, and also like which node, and if you want to retrieve it, you can using the code here. And yeah, and the fund needs data oracle to approval for the unlock, because we needed to make sure like the data on chain, then we are going to pay back. It's cross chain, which means from Filecoin to Polygon network, we rely on those oracles to get the data back. And this is the past payment consensus, payment struct contract. You can see the logs. If you analyze the logs, it will tell you like the data, original ID, the task IDs. We have something called Web3 IDs. So it's on top of the data IDs, you will have different IDs. If your storage is too small, we are building something like a sidecar to enable multiple files compressed together, become one bigger car file, because nobody actually will really accept the 3 megabyte storage deals. So we are like compress over 1,000 deals in some contract and doing the unlock. After everything is there, you can put the NFT mint functions, and also by MetaMask, and it will mint on the OpenSea testnet. Like, yeah, it takes a couple of seconds for the validation about the transaction. Yeah, so now you can see the image is loading will take a while, but you can see like it's already become NFT. So if you have important data, you're doing the training, or you want to doing the labeling, and you find you think it's a high value, you can using this function, doing the one click to doing the transfer, listing on OpenSea and for sale. Also, you can do the same thing for your training result. About the training part, I just give you an example. This is the famous monkey things we have. So writing something directly fetch, if you already uploaded the data to the IPFS node, we're doing a small thing, you can direct downloading the data from IPFS. So we have other script help you for downloading. And if you already have it downloaded, so we can just start training from locally instance. This is optimized for M1 computer. So you can see like this is training with a sample data set. And yeah, we have the training ongoing. It takes a couple of 1 minute or 2 minutes to get all the data. And then also you can passing the training result back to the storage node. So I hope like bucket team can make something of those training algorithm become container based or something like that, so we can deploy it on the same node of the Filecoin sailing servers. And if we can make the storage node and the computing node as close as possible, it will be much easier for people to do the training, since we have the CID running on the same edge environment. That will be a great advantage for us. So we're working on bridging those things when everything is ready to use. Yeah, so this is doing the plot, image training. Yeah, so it program different species of the monkeys and have a timestamp here. Yeah, so currently, like, we already have over 50 nodes worldwide running the our storage Swarm providers with integrated with storage and other functions. And which means that we have the potential, if we have the computing nodes integrated together, we can distribute to those 50 nodes worldwide. Currently, like, we have 2 big nodes owned by Swan team, which is one is in Canada, has about over 1,000 servers, and also in North Carolina, East US, with over 300 servers computing power with storage together, can provide over 10 petabyte storage for the computing task. And the entire network is even bigger than that. So that's why we added the payment part. If we can get payment incentives for our user, that will be great for them to doing the training jobs. And the same Oracle structure we had before will be also used for the computing task. So if you guys can, or anyone can give us a proof of work of computing done, something, it can either be a ZK or transaction hash or task completing hash, we can put it in Oracle back to smart contract. We're using the same stack to integrate computing and storage, because another Web3 computing task distributed on different networks. Yeah. So we have a timeline here working on the DAO algorithm about the treasury management, proving voting, and also arbitrage if it's a case of claim happens. So the edge computing, we're aiming at start of the integration work Q1 or Q2, depends on if we found good candidates. That's the first approach of integration. And on the Q3, we would like to integrate the CDN capability in the geo distribution node worldwide. So like we can move the computing task and the data as close as possible. Yeah, so currently like Binance Labs Session 4 project, also like sponsored by the ProLab, Channing, Beach Capital, and other capitals as well. Yeah, and our Twitter is the first one, OX first one. So yeah, that's pretty much it.
Lovely. Charles, thank you so much. I'm super interested, particularly, there's so many use cases where if I'm a compute over data developer and my ecosystem is very Ethereum centric or very Matic centric, and I don't have, maybe I don't have Filecoin integration today, but I could use your service to simplify and just pay in my native currency that with my wallet dApp that I built, and let you guys manage the backend storage. Should I think of MCS as, is there a exchange process between my native token and the fill tokens that would happen, or does it just get locked up somehow as wrap tokens?
Yeah, so basically here has, we don't have exchanges. We're using existing exchanges. For example, Polygon network will be Sushi, BSC network will be the Pancake, Ethereum network will be Uniswap. We're using the existing exchanges to do the token swap. We don't manage the DX exchanges. That's too much risk. So which means that you fund is safe. You only pay for usage. So which means that you don't really need to prepare Filecoin tokens like 3 weeks ago. It's just like when you use it, you pay with USDC or token we might have in the future, and get it what you need.
Very good.
So where,
Lovely. Please.
where does the expense for gas fees go if like you're switching between changes? Or
Yes,
currencies?
the gas fee actually is a part of smart contract. It will deduct from smart contract because everything when you're doing the swap is on the same network. So we are calculating the gas fee, locked in fund, and it will be deduct from there. The Polygon network fees currently is very slow, very small. That's why we choose Polygon and the first one. Or maybe like integrate other Ethereum layer 2 solution as well. So the when it's running on Ethereum network, it becomes tiny as well. So currently like the less than 1 cent on the Polygon network. But also it also actually costs some Chainlink tokens as well, because we're doing oracles about approve, you need to using some tokens. But the good news is that we're doing the batch approval, which means that we're not doing the single file approval. So every 2 hours, we are like we are approve all the nodes at the same time. So which means that you will unlock the funds with the 1,000 other users together to so which means it's much slower, much small. I mean,
Understood. This is very interesting. All these projects are interesting. Damn it. It's too much to think about.
yeah, exactly.
Let
I'm
me use
so
that
curious
as a
about-
moment. Let me use that as a moment to step in. We don't just meet, once every 2 weeks. We have a very active Slack channel. We would love to talk about this with everyone as a community. Please do come join the Slack channel and continue the conversation. Let me add additionally a little bit of housekeeping before we run out of time. We are planning on November 2nd and 3rd in Lisbon. This will overlap with Web Summit, so those already going, you'll already be there. We are planning to do a Compute Over Data Summit and would very, very, very much love to have each of you have a short presentation there. Obviously we're going to work really hard to get a lot of people attending. You can show off your stuff. You can work with me. I have a lightweight session doc or a schedule that we're working through to figure out what the schedule looks like. But it very much should feel like a community-driven thing. 2 days, we have the space, and we would love to see you all there.
Very good. All right. Well, I think we can go ahead and wrap unless anybody has anything else for today. All right. Well, much fun. Thank you, Charles and James and Jonathan, so much for presenting today, and looking forward to continue the conversation in the next session. Thanks so much, guys.
Thanks.
Awesome. Thank you.
Okay, bye.
Thank you. Bye.
Thanks. Bye.